Welcome to Sun Facts: 50 Mind-Blowing Things Our Star Does. A deep dive into the giant glowing ball's incredible power, mystery, and behavior that keeps us alive. Let's get started. Structure and composition. The Sun is a massive ball of plasma made up mostly of hydrogen and helium. It contains 99.86% of the total mass in our entire solar system, more than 330,000 times the mass of Earth. At its core, the Sun reaches temperatures over 15 million degrees Celsius. This is where nuclear fusion happens. Atoms of hydrogen fuse to form helium, releasing enormous amounts of energy that power the Sun. The Sun has several layers: the core, radiative zone, convective zone, photosphere, chromosphere, and corona. Each plays a unique role in generating, transferring, and emitting the Sun's energy and light. The visible surface of the Sun, called the photosphere, is surprisingly cool compared to the core, around 5,500 degrees Celsius. Yet it's bright enough to blind you instantly if viewed without protection. Despite being a giant ball of fire, the Sun is not solid. It's made of plasma, a superheated, electrically charged gas. Its magnetic fields twist and snap due to this flowing plasma. The corona, the Sun's outer atmosphere, is hotter than the surface, sometimes reaching 1 to 3 million degrees Celsius. Scientists are still trying to understand why it's so much hotter than the layers below. Our Sun is classified as a G-type main sequence star, or G-dwarf. It's a relatively average star in size and brightness, but perfectly suited to support life on Earth. The Sun's light takes about 8 minutes and 20 seconds to reach Earth. That means every sunrise you see is already more than 8 minutes old by the time it hits your eyes. Hydrogen fusion in the core converts 4 million tons of mass into energy every second. That energy radiates outward, fueling the Sun's brightness and supporting all life on Earth. Even though it seems constant, the Sun is slowly losing mass. It loses about 1.3 million tons every second due to nuclear fusion and solar wind. Over billions of years, this will change its structure. Motion and orbit. The Sun doesn't stay still. It orbits the center of the Milky Way galaxy at about 828,000 km per hour. It takes roughly 225 to 250 million years to complete one galactic orbit, a cosmic year. Unlike Earth, the Sun doesn't rotate as a solid body. Its equator spins faster than its poles, taking around 25 days at the equator and up to 35 days at the poles to rotate once. The Sun's gravitational pull keeps all planets, asteroids, comets, and Kuiper belt objects in orbit. Without it, the solar system would instantly fly apart into space. As the Sun moves through the galaxy, it drags the entire solar system along in a massive spiral motion, creating a vast cosmic tail known as the heliotail. The Sun wobbles slightly due to the gravitational influence of the planets, especially Jupiter and Saturn. This motion can be detected and is used to study both the Sun and distant stars. It's located about 27,000 light-years from the center of the Milky Way. Despite its distance, it orbits our galactic core once every 230 million years. The Sun lies inside a region of space called the local bubble, a cavity carved out by ancient supernovae. This bubble protects us from some of the galaxy's harshest radiation. The solar system orbits within the Orion Arm, one of the smaller spiral arms of the Milky Way. Our Sun is just one of more than 100 billion stars in the galaxy. The Sun is slowly moving toward the constellation Hercules at around 70,000 km per hour. In thousands of years, the night sky will look drastically different due to this stellar drift. From Earth's perspective, the Sun seems to rise in the east and set in the west, but it's Earth's rotation causing that. The Sun is nearly stationary relative to us. Solar activity and magnetic phenomena. The Sun's magnetic field is constantly shifting. About every 11 years, the Sun undergoes a magnetic flip, its north and south poles reverse, triggering dramatic changes in solar activity. Solar flares are sudden, intense bursts of radiation from the Sun's surface. They can release as much energy as 1 billion megatons of TNT and interfere with satellites and radio signals on Earth. Coronal mass ejections, CMES, are massive bubbles of solar plasma ejected into space. If directed at Earth, they can disrupt power grids, GPS systems, and even cause auroras near the poles. Sunspots are dark patches on the Sun's surface caused by magnetic disturbances. They're cooler than the surrounding areas but often larger than Earth and are key indicators of solar activity cycles. The more sunspots there are, the more active the Sun is. These cycles, which peak roughly every 11 years, affect solar radiation and space weather across the solar system. Solar wind is a continuous stream of charged particles released from the sun's upper atmosphere. It shapes Earth's magnetosphere and creates breathtaking auroras near the polar regions. Earth's magnetic field acts like a shield against the solar wind, deflecting most of the charged particles, but strong solar storms can penetrate and cause geomagnetic disturbances. The sun generates a heliosphere, a vast bubble of solar wind that stretches well past Pluto. It forms a protective shield against some of the galaxy's cosmic rays. Auroras, or the northern and southern lights, are created when solar wind particles interact with Earth's atmosphere, exciting oxygen and nitrogen atoms and producing colorful displays of light. During periods of high solar activity, astronauts aboard the International Space Station must shelter in shielded areas to avoid harmful radiation from solar flares and coronal ejections. Life cycle and future. The Sun is around 4.6 billion years old, about halfway through its life cycle. It's expected to shine as a stable main sequence star for another 5 billion years. Eventually, the Sun will run out of hydrogen fuel. It will swell into a red giant, engulfing Mercury, Venus, and possibly Earth, as it burns helium in its core. After the red giant phase, the Sun will shed its outer layers, creating a stunning planetary nebula, a glowing shell of gas expanding into space. What remains after the Sun's death will be a white dwarf, an Earth-sized, extremely dense stellar core that slowly cools and fades over billions of years. Despite its dramatic end, the Sun isn't massive enough to become a supernova or black hole. Only much larger stars undergo such explosive deaths. As the Sun ages, it will get brighter. Scientists estimate that in about 1 billion years, increased solar radiation will make Earth too hot to sustain liquid water. Before it becomes a red giant, the Sun's increasing energy output will slowly strip away Earth's oceans and atmosphere, making our planet uninhabitable long before the final explosion. The Sun's stable energy output has allowed life to evolve on Earth over billions of years. Without it, Earth's surface temperature would drop to below -200 degrees Celsius. Some scientists propose building a solar shade, or moving Earth's orbit outward in the far future to avoid being scorched by the Sun's increasing brightness. All elements heavier than hydrogen and helium on Earth, including oxygen, carbon, and iron, were formed in stars. The Sun's birth was made possible by earlier generations of exploded stars. Observation and cultural impact. Ancient civilizations like the Egyptians, Aztecs, and Greeks worshipped the Sun as a god or supreme being. Solar deities were often central to mythology and calendars. The solar calendar, based on Earth's orbit around the Sun, is the most widely used system today. It ensures predictable seasons and agricultural cycles across the globe. The Sun appears yellow or white from Earth, but in space, it's white. Earth's atmosphere scatters shorter blue wavelengths, making the Sun seem warmer in tone from the ground. Solar eclipses happen when the Moon passes between Earth and the Sun. Total eclipses reveal the Sun's corona, normally invisible, and are rare, stunning events. Studying the Sun helped confirm Einstein's theory of general relativity. During a 1919 eclipse, scientists observed the bending of starlight near the Sun's edge, supporting the idea that gravity warps space. Solar energy can be harvested with photovoltaic panels, turning sunlight into electricity. It's one of the most promising renewable energy sources for a sustainable future. NASA's Parker Solar Probe, launched in 2018, is the closest human-made object to the Sun. It's flying through the corona to study solar wind and magnetic fields up close. Even from 150 million kilometers away, the Sun's energy powers photosynthesis, weather, ocean currents, and almost every natural process on Earth. The term solar constant refers to the steady flow of solar energy received per square meter at Earth's upper atmosphere, around 1,361 watts. Without the Sun, the solar system would freeze, and life on Earth would end. It is, quite literally, the reason we exist, a glowing furnace of life, light, and energy. Thanks for joining us on this journey through 50 mind-blowing Sun facts.